Hello, welcome back to my channel, Jerome PH Official, and today's video is about radicals. And kung hindi ka pa nakasubscribe, pindutin lamang ang red button sa baba and hit like, share, and comment if you want. Huwag na natin patagalin, simulan na natin. My intro begins. Good morning, good afternoon, or evening guys. Today's video is about radicals. What is radical? Roots or radicals are the opposite operation of applying exponents. We can undo a power with a radical. We can undo a radical with a power. For instance, if we squared 2, we get 4. And if we take the square root of 4, we get 2. If we square root 3, we get 9. And we take the square root of 9, we get 3. We can raise numbers to the powers upper than just 2. We can cube things, being raising things to the third power or to the fourth power. Raise them to the fourth power or the fourth power 4. Raise them to the 100 power and so forth in the same way. We can take the cube root of a number, the fourth root, the 100 root, and so forth. Just as the square root and those squaring, so also the cube root and those cubing. The fourth root and those raising things to the fourth power. Etc. to indicate some root other than a square root when writing. We use the same radical symbol as for the square root, but we insert a number into the front of the radical, writing the number small and tucking into the checkmark part of the radical symbol. This tuck in number corresponds to the root that you are talking. Simplifying square root terms. To simplify a term containing a square root, we take out anything that is a perfect square. This is we factor inside the radical symbol, and then we take out in the front that symbol anything that has two copies of the same factor. For instances, 4 is the square of 2, so the square root of 4 contains 2 copies of the factor 2. Thus, we can take a 2 out front, leaving nothing but an understood 1 inside the radical. Note that the value of the simplified radical is positive, with either of plus 2 and negative 2 might have been squared to the get 4. The square root of 4 is defined to be only the positive option, positive 2. This is the definition of the square roots. Says that square root will spit out only the positive root. On a side note, let me emphasize that evaluating an expression to find it is only value and solving an equation to find its one or more or no solution. And solving an equation to find its one or more or no solution are two very different things. In the first case, we are simplifying to find the one defined value of for an expression. In the second case, we are looking for any and all values that will make the original equation true. Oftentimes, the argument of a radical is not perfect square, but it may contain a square amongst its factors. To simplify the sort of radical, we need to factor the argument that is factor whatever is inside the radical symbol, and take out one of the anything that is a square. That is, we find anything of which we got paired inside the radical, and we move one copy of it at front. When doing this, it can be helpful to use the fact that we can switch between the multiplication of the roots and the root of a multiplication. In other words, we can use the fact that radicals can be manipulated similarly to the powers. Multiplying square roots. The first thing you learn to do with square root is simplify terms that had or multiplied roots. Simplifying multiplied radicals is a pretty simple, being barely different from the simplification that we already done. We use the fact that the product of two radicals is the same as the radical of the product and vice versa. Yes, the term manipulation was fairly simplistic and wasn't very useful, but it does show how we can manipulate radicals, and use the manipulation is working in the other direction can be quite helpful. When multiplying radicals, as this exercise does, one does not generally put a times symbol between the radicals. The multiplication is understood to be by just that juxtaposition. So nothing but further is technically needed. To do this simplification, it's first multiply the two radicals together. This will give me 2 times 8 equals 16 inside the radical, which I know is a perfect square. By the way, I could have done the simplification of each radical first, then multiply and then does another simplification. The work would be a bit longer, but the result will be the same. And adding and subtracting radical. Just as with regular numbers, square roots can be added together, but you might not be able to simplify the addition all the way to one number, just as you can add spice and oranges. So also you cannot combine unlike radical terms. In order to be able to combine radical terms together, those terms have to have the same radical part. Since the radical is the same term in each term, being the square root of 3, then these are like terms. This means that I can combine the terms. I have 2 copies of the radical added to another 3 copies. This gives me a total of 5 copies. Hot middle step with a parenthesis shows the reasoning that justifies the final answer. You probably won't ever need to show the step, but what should be going through your mind. It can only combine the like radicals that first and last terms contain the square root of 3, so they can be combined. The middle term contains the square root of 5, so it cannot be combined with the others. So in the case, I end up with the 2 terms in my answer. I start by rearranging the terms to put the like terms together, and by inserting the understood into the second square root of 3 term. By doing multiplication vertically, I could better keep track of my step. You should use whatever multiplication method works best for you. But no, the vertical multiplication isn't temporary trick for a beginning students. I still use the technique because I found that I'm consistent, faster, and more accurate when I do. Conjugates and dividing by radical. Sometimes you will need to multiply multi-terms expression which contains only radicals. This is a situation for which vertical multiplication is a wonderful help. In the last example above, how I ended up with all whole numbers. Okay, technically they are integers, but the point is that terms do not include any radicals. I multiplied 2 radicals binomials together and got an answer that contains no radicals. You may also have noticed that the 2 binomials were the same except for the sign in the middle, and one had a plus and the other had a minus. The first of factors with the second factor differing only in the one side in the middle is very important. In fact, the same expert for the sign in the middle second factor has its own name. Yun lang. Okay guys, yun lang. For meantime, puputulin na natin tong video na to kasi nagkaroon na tayo ng 5 topics sa radicals. And sana nag-enjoy na kayo. And please like, share, and subscribe to my channel, Jerome PH Official. And leave a comment kung nagustuhan niyo tong video. Yun lang, and maraming salamat sa pag-subaybay sa ating vlog. And happy 2022. First vlog ko to sa 2022, kaya happy 2022. And today is February 2, 2022. And yun lang, my outro begins.